Well, hello, my name is Jevgeni, and I'm from PipeDrive, and on this session I will be talking about statistics based on the test data. Well, I have been working in the software development industry for 7 years now. And during my journey in this field, I managed to participate in a lot of different software testing activities, starting from organizing a software testing process from scratch and ending with developing the utilities to improve product's quality. Additionally, I always loved analyzing different software bottlenecks, identifying what caused the problems and applying new approaches to solve them. And basically this experience led me to Nordic testing days, where I want to talk about my experience of collecting the test data and applying it with an aim to improve product's quality. But first things first, let's briefly cover the session topics that I will be talking about. Firstly, I want to give you my vision of why we should collect the test results. Then we will briefly cover the test metrics definition and why they are needed. Then I will tell you two stories from my real experience when we were investigating why did we have a poor quality and where did bugs come from. Then we will make some conclusions based on these stories and of course discuss how and where we could collect the test metrics. Of course, in the end, we will have some questions and answers around, so if you have any questions, you can feel free to ask them in the end of my presentation. But, why should we collect the test results? I think that we evaluate different things probably every day. In our common life, we estimate if the weather is good or bad today, whether you like this t-shirt or not, or does cat behaves well or badly. At work, we are evaluating our tasks like planning was done well, but the test process could be organized better and the results could be analyzed. But these assumptions are always based on the subjective perception, and higher details are always needed. Additionally, in the last few years of testing, I noticed that quality assurance engineers limit themselves to analyzing the requirements, covering them with the test cases, and eventually running the manual or automated tests until product responds to the claimed quality marks. And basically that happens until problems that had to be addressed weeks, months, or even years ago become challenging to fix. But how can you assess your project's growth and prosperity if you are not gathering any information that can give you a hint that something goes wrong? How can you react quickly if you don't even know that problem exists in your project? And how can you understand what should be improved if you're not gathering any information and you don't have any alerts for understanding that you have problems in your project? Well, for all of these questions, I have one answer: statistics. And yes, when you hear this word in the context of testing, you might have already thought that this much better applies to software management fields or even to the sales field, but not related to testing process itself. And each time introducing quality assurance metrics to my team, they felt uncomfortable because you have to collect additional information, measure the results, and analyze collected data. And it looks like you are bureaucratizing everything at the first sight. But when we got first benefits from any metric, the laziness was replaced by discipline and deep understanding the importance of quality assurance metrics. And if it didn't happen, then the metrics can be safely thrown away. And because of that, I will not provide you different lists of metrics and different formulas, and I will just share my experience of collecting the test results and what results I have achieved after I started using them. Well, firstly, let's refresh our memory and talk about what the test metrics are. So the measurement is a quantitative indication of some amount or size of something, like products or software. And as samples of measurements, we can use the kilometers, hours, bugs, or features. And the metric is a derivative of two measurements, and it could be kilometers per hour or bugs per feature. Well, and the main purpose of the test metrics is that they should have a goal of understanding and improving the process. And this is necessary to make the testing more transparent, because transparency will give us an opportunity to see all the issues, boldly talk about them, and as a result of this process to be able to solve these problems. One more important reason of the test metrics is that they are decision points that will lead you to take an action, and how effective those actions are in improving your testing process depends on the metrics you choose. Of course, test metrics will help you to understand if the solution you have chosen for fix the issue will give you a hint that this solution helps to remedy the situation. And finally, this data could be used to judge your productivity and efficiency over time. And let's move on to experience I gained while I was working on one of my projects. So once my task was to analyze what causes the bad software quality and in some way to solve this problem. So I decided to begin from the very obvious thing by estimating the percentage of missed errors. So, and additionally, I decided to start from the errors that were reported by our customers. So I added to the bug submission form informed by customer fields, marked in that way the old bugs, and counted them. So it appeared that slightly more than 5% of issues were informed by our customers, and it looks like everything is good with our solution. So then we decided to dig deeper and add one more additional field to bug submission form that called reproducible in the release version. So each time the new error was registered from the test environment, quality assurance team checked whether this issue reproduces in live. And it appeared that almost 40% of our issues are reproducible in production. So basically it turns out that our customers don't report about problems in our solution, but they formed an opinion that our software sucks. Well, thanks to that investigation, we formed two new metrics. The first one is a percentage of errors that are reported by our customers, and the second one is the percentage of errors that fall into production. So we decided that we don't want to have more than 10% of errors that are reproducible in life. But how this can be ensured? Should we expand resources and then expand our team, or maybe we should deliver less features per release for our customers, or maybe we should even increase the deadlines and spend more time in testing. For understanding this, we decided to dig further and look for new metrics. So we decided to add one more extra field called reason for missing the defect, to understand why we are missing defects in test environments and to define those reasons for the quality assurance team. So the list of those options was as follows. We didn't take the test into account, like quality assurance team didn't know that it could be tested in that way. The second option was that the feature was not tested, like we had a test, it passed once, but then the functionality was broken and we didn't perform the regression testing. And unknown requirements, like quality assurance team didn't understand or didn't know that it could be tested or should be tested in that way, or how it should work or look like. And as a result, for the first months, it turns out that 60% of our issues are connected with a misunderstanding how it should be tested, and 60% of errors were missed because testers didn't even know that it could be tested in that way. And brainstorming how to solve this riddle led us to various solutions, starting from conducting grooming and retrospective meetings by improving the test planning, improving test planning again with involving the analysts and developers into this process, and conducting the interviews with our customers to understand their environments. And slightly implementing these new procedures, we managed to reduce missed errors percentage from 60% to 20%, and we managed to achieve these results without expanding a team or increasing the deadlines. So basically, test metrics helped us to understand what causes the issues, and that we have an issue with our software And basically, that's a pretty good result from my point of view. The second story happens when we were developing some necessary and, of course, useful service for some governmental structures. And I saw that we have a pretty good organized software testing process, and we had a pretty good percentage of missed errors into production, but I saw that at the same time we had a lot of found issues by the quality assurance team, and that probably means that something is wrong on the development side. Considering what we are quality assurance engineers and it requires to have some analytical skills, I began the investigation, and it turns out that we had from 15 to 40 issues per feature, and time for fixing those issues took as much time as the development of the feature itself. So we wanted to understand, like, why do we have so many issues and why developers are producing so many errors in their codes. So for that reason, we added one more extra field to bug tracker form called error root cause. And this field was mentioned for developers to be filled in by themselves to understand why the issue initially appeared. Because when the developers are committing their changes to master, they already know what's caused the issue. So the list of options was as follows. Changing requirements, like developers did their job, but then the product owners looked at the results and said, not really, let's make it in other way. The code, like the human error, bad code, or any other reason that could be related to the test design. And requirements misunderstanding, like developers didn't understand how the feature should be developed or how it should work like. And as a result of this investigation, it turns out that less than 5% of issues were related to the changing requirements. And to be honest, developers were really surprised because they thought that that was the main reason of why they're missing the defects. But they had to agree with these results because they filled in this field by themselves. The second reason was that the bad code, and we had 30% of issues that were connected with this reason. And almost 65% of issues were caused by the requirements misunderstanding. So it turns out that developers don't understand what they're doing or like how it should work like. Trying to solve this issue, we found a lot of different solutions, starting from reorganizing the process of how we create the documentation and hiring the technical writer who will write everything in the developer's way. Improving the development process by discussing feature development on each iteration and conducting the grooming and retrospective meetings for the development team. And involving quality assurance engineers to the development process so they can prompt in advance what kind of tests and complex tasks they will execute against the new feature. And again, slightly implementing these new approaches, we managed to decrease the bug counts that were caused because of the requirements misunderstanding. Has slightly begun to decrease from 65 to 20% within 6 months. And again, like we basically only analyzed what causes the issue, that we have an issue with our solution, and we used the test metrics to solve this problem. And returning to stories I told you, we can conclude that we should notice the problems before they appear in your projects, and it's a not very good way to fight against the issues that are arising and fighting against the consequences that are appearing because of those issues. And to understand how effective your test cases and the test suits are, we should collect the indicators at different time and compare them to each other. And one of the useful charts for understanding the general state of your project is the defect age chart. So basically each column represents the number of days that are required for the development team to fix the issue. So it's basically the time difference between where defect was detected and the defect was fixed. And the higher column is, the more days it takes to fix the issue, and that probably means that either the bugs are too complex and too critical, or there are a lot of issues in the backlog of the development team. The purpose of the test effectiveness metric is to show how many errors on average your test cases can detect, or a number of bugs per test. So this metric allows you to monitor the effectiveness of your test cases and monitor the trends of their changes. So creating visibility around how it changes over time will give you an opportunity to make an appropriate decisions on when and how to improve your tests and update them with fresh ones. For defect density metric, we calculate the percentage of defects in a software or in a particular solution or particular feature. And the purpose of this metric to show and understand how problematic our software or feature is. And this information will help you to evaluate in the evaluation planning and risk analysis of your software, and because it will immediately turn your attention to the problem zones. And the purpose of the final metric is to demonstrate the quality of testing and the test effectiveness of your cases. And basically it shows the percentage of the defects that were filtered out and how many issues passed to the live customer. So if for the release the test effectiveness is 80%, that probably means that 20% of defects got away from the testing team. And this metric helps to observe the effectiveness of testing, as well as to understand that your test cases began to lose your efficiency. Well, how and where to collect the test metrics? Basically, we have three different sources for doing this. The first one is your bug tracking system. It could be Jira, Bugzilla, or any other that you're using on your projects. Considering that you have all the issues in one place, you can gain the information about what is the issues count, what is their defect age, defect density, what is the test effectiveness, and so on and so on. Basically, in Jira, there are a lot of free and embedded plugins that could help you to build the beautiful graphs and visualize everything and to see all the issues like on one dashboard. The second place is your test management system. It could be Test Trail, HP Quality Center, and so on. Considering that you are storing all your test cases in the test management system, you can collect information about the test counts, their average execution time, what is the error rate, and what are the most failing features, and so on and so on. And the last but not least is the continuous integration system, like Jenkins, TeamCity, or any other. There you can collect the information about the average execution time for your automated tests, their error rate, what are the most failing tests, and what are the most time-consuming tests, and others. In a more advanced level, you can parse all this information from all sources and migrate this information to some database to have everything in one place. But to start with, you can begin by collecting this information like system by system and step by step. And when you will understand what kind of information is useful for you, and when you will start to understand how it could be used for your project, you can move on to some advanced levels of matrix collection. So basically that's it. I hope that you will start collecting the information and analyzing what causes the issue, and start to understand that how it could be done. And if you have any questions, I'm ready to provide an answers to you. And in the meanwhile, you can read these beautiful quotes told by Lord Kelvin. and he covered this topic in 2 sentences instead of talking for 20 minutes. Thank you.
Hi, thank you for your talk. My question is, how did you persuade your developers to fill in the root cause field honestly and not to be blamed for it? Because at my previous place of work, the problem was that they filled in like bad code as the reason of the issue. And so for some of the managers, that meant bad code. That means that you're a bad developer. So like you're fired, something like that.
I understand this problem. Like we were trying to be honest with each other, and we were asking for the developers and the testing teams to make the process more transparent. We have to be honest, and like we were trying to explain that our opinion could be useful and what could be done to understand the issues, and basically we just trust in our developers, and like it's worked for us.
Hello, thank you for the talk. What issues do you measure in your statistics? I mean, severity of issues. So it's only criticals or criticals and measures, blockers. Because on production we could have like many minors and everyone is okay with it.
We're trying to collect information about any type of the issue, like to understand what is the average number of issues we found, and to understand what is the trends of this metric. Like if it grows, like we understand that something is going wrong with the development or with the quality assurance team. Like we don't divide them into the different types of like critical, major, or so on. Yep. There's one more question.
Maybe there's even 2. While I walk, I'll ask you a question. Good point. I can't do 2 things at a time. My question is that how many fields did you end up having in the bug reporting tool? And how did people actually, accept that there's yet one more field to fill out?
Once we had almost 6 additional fields that we had to fill in, but after we analyzed all this information and made some solutions and improved the process, we just dropped them from the bug management system. And basically it was not kind of a huge headache for us.
Okay. I would like to ask that, did you categorize the defects basically you picked up? Because for example, for the performance testing, you can open the thousands of issues or the failure, but for function testing, that you could find much less, but the severity might be very high. If you only check the metrics, the numbers, but you are not categorize your defects, it might make your metrics invalid.
Thank you for your question. Like as I said before, like we were not dividing them into different types and different severities, and we were just trying to understand what is the average number of issues we found in our solution. But basically it depends on your needs. Like if you want to understand how many major or blocker issues you find in your solution, then you can split them into different threads and different groups and start collecting this information as well.
So the answer that you are not category defects?
Yeah, we don't.
Okay, thanks.
Yep.
So how do you separate the signal from the noise?
What do you mean by this?
If you don't categorize at all.
Well, I didn't get the question. Like.
All right, we'll take it later.
Yeah.
No worries. More questions? Yep.
You mentioned the size of the software. I mean, seeing lines of codes and complexity doesn't really correlate.
Like we were comparing this information to lines of codes and to number of test cases and to different criteria that could help us to understand what is the correlation between the found issues and the size of the project.
Okay. More questions? Yep.
So generally, how much trust do you put in these numbers that you get? Because I mean, they are useful, but I see a very big risk of false positives and so forth.
Like, basically, in some cases, we can trust into these metrics because we were collecting this information from the test cases, like their execution time, their like different trends of their, I don't know, failing cases and so on and so on. In some cases, we had to trust in the results that were filled in by our not customers but developers and the quality engineering team. But as I said before, we just explained them that it is necessary to fill in these fields. And to be honest, why you are filling it in, because we're not going to blame you like your code is bad or something like this. We just want to understand what causes the issues and how to solve these problems, because it will eventually help the whole team to increase your productivity and spend more time on, I don't know, on developing new features instead of fixing the bugs and that stuff.
So just so I understood it correctly, you used it more as a warning sign than like a guiding line.
Yeah.
Good.
Yeah. More.
I just mentioned that my talk will be very quantitative estimation. So welcome to my talk.
Okay. So no question. Maybe somebody else has a question.
There is one.
Okay, good.
Hey, thanks again for the presentation. I just wanted to ask, you didn't really categorize the types of bugs, but for instance, did you notice that maybe you had some problematic areas? So for instance, maybe there were several smaller bugs that weren't necessarily that important, or they just came along, you know, once in a month or something, but eventually you decided that, okay, these are coming from a different from the same area. And did you have any cases where you found a problematic area by analyzing these details, like, you know, after like 3 months you realized, okay, there's a problem here?
Yeah, basically we were trying to, and we did it like organizing the metrics between different features to understand how the problematic our different like particular feature are, and it helped us to understand like we had some very clean code in some features and very properly tested everything there, and some features were too problematic, and we understood that we should do something with them, like automating them to decrease the errors, like percentage of errors that we miss there. So yeah, but still it depends on the project you are working on, and if you want to understand how problematic the features are, or maybe some other part of your project, like you can categorize them as well.
Yep, we have more questions and we've got time for them.
So you've mentioned that in one of your cases you decreased the number of errors from 65% to 20%.
Yeah.
And also you've mentioned that you, in a while, you removed the obligatory fields from Jira, for example,
yeah.
right? So can you please tell me how often do you analyze this data? And how do you decide that, okay, this decreasement, it's okay, and we stop here?
Mm-hmm.
And so you decreased the number of issues due to not understanding the acceptance criteria, right?
Mm-hmm. Mm-hmm.
But did the overall bugs also decrease? Because maybe another issue was appearing, I mean, another cause.
Yeah. So basically, after we analyzed and collected information about what caused those issues that I was talking about, we dropped all those fields from the bugs tracking system, but at the same time we had some default graphs and statistics that we were collecting about the defect age, about the most failing features and test cases and so on and so on. So if we saw that something is going up, or like something changes there, and our average like test cases passing rates or error rate is increasing. So that was a sign that we should react somehow and start investigating and digging into this problem. And by adding probably some new metrics, or just talking to developers or inside the quality assurance team to understand like how it could be solved or how it could be investigated, to understand what is the cause of this issue. Yeah, for a couple of months to understand, to get the sense of what's going on there, and after we collected this information and analyzed it, we just dropped it. But that they exist there for 4 or 6 months, yeah.
I'm a bit confused. I mean, you've added the fields in order to find out why.
Yeah.
And when you find out why, you are dropping them.
Yeah.
Then how do you measure that in 6 months you decrease the number by several percent if you don't have the fields after 6 months?
Yeah. Like we still were collecting the information, and we added it back again to understand if we had this, we have the same number of issues or not, but as well we had some additional graphs that were indicating that we don't have any more issues in that feature, or in that team.
So every couple of months you are adding back the.
Sometimes it happens, yeah.
I see in my mind the eyes of developer who is just not willing to add any more info.
Basically, that's your how you do behave with the developers, and if they understand that it is needed for solving some issue, so they will not say something that's what are you doing and why we need it.
So always start with why, yeah? Okay. There's one more hand I see.
Hey, thanks for a good talk. We're doing something similar on my project, and it's very good to hear about others' experiences. To what extent did you involve the developers or others, like project managers, in the whole this whole thing?
Like how we did it?
Strategy and everything?
Like how we did it, or?
No, just from the beginning. Did you involve others, or was it just a test group?
No, in the beginning it was only the testing group, to understand if we have some issues, and maybe those assumptions are false, and we try to understand it in our small kind of a testing group, and later we talked to the product owners that we want to start the investigation and to start collecting different information and adding new fields to the different forms to track this.
And the solutions, did you come up with them together with?
Yeah. Then we made some kind of focus group that were helping us, and we were working together to find some solutions to solve this without applying some hard decisions, or increasing the teams, or something else, and starting from the easiest way to solve the solutions. And to find the easiest way, it is reasonable to find the error, the root cause of this issue, and that really helps.
Thank you. So I think we've got time for a couple of more. You don't want me to start with question assurance now, do you? Okay. Thank you for a very specific and awesome talk.